Welcome to our exploration of permafrost and carbon bombs. In this video, we'll delve into the crucial relationship between permafrost and climate change, examining how this frozen ground acts as a giant carbon store. As temperatures rise, the thawing of permafrost poses significant risks by releasing stored carbon, creating a feedback loop that can accelerate global warming. Join us as we uncover the science behind permafrost thawing, its environmental impacts, and the urgent actions needed to address this environmental challenge. 1. Understanding permafrost. Permafrost is frozen ground that remains solid for at least 2 consecutive years. It is prevalent in high-latitude regions such as Siberia, Alaska, and Canada. Covering roughly 24% of the Northern Hemisphere's land area, permafrost plays a critical role in the Earth's climate system. Imagine the ground being a natural freezer, preserving ancient plant material and soil. This frozen layer has been a silent guardian for centuries, locking away vast amounts of organic carbon. However, with the world getting warmer, this once stable freezer is beginning to thaw, posing significant challenges for our planet. 2. Carbon storage in permafrost. Permafrost serves as an enormous carbon reservoir, containing about 1,500 billion tons of organic carbon. To put this into perspective, it holds nearly twice the carbon currently present in the Earth's atmosphere. This carbon is not just any carbon, it's ancient plant material and soil organic matter that has been trapped in ice for millennia. Think of it as a time capsule, preserving the Earth's history in the form of organic matter. The sheer volume of carbon stored in permafrost highlights its significance in global carbon cycles and its potential impact on climate change if released. 3. Thawing permafrost and carbon release. As global temperatures rise, the permafrost is beginning to thaw, releasing stored carbon dioxide, CO2, and methane, CH4, into the atmosphere. Methane, in particular, is a potent greenhouse gas, about 25 times more effective than CO2 over a 100-year period. This means that even a small release of methane can have a significant impact on global warming. The thawing of permafrost is akin to opening a Pandora's box, where the release of these gases could exacerbate existing climate issues. The potential consequences of this release make it a pressing concern for scientists and policymakers alike. 4. The feedback loop. The release of greenhouse gases from thawing permafrost creates a positive feedback loop. In simpler terms, the more the Earth warms, the more permafrost thaws, leading to more greenhouse gases being released into the atmosphere. This process amplifies global warming, making it increasingly challenging to keep temperature increases within safe limits. It's like a snowball rolling downhill, picking up speed and size as it goes, potentially leading to more severe climate changes than we currently anticipate. Understanding this feedback loop is crucial for predicting future climate scenarios and developing effective strategies to mitigate its effects. 5. The permafrost carbon bomb. The term carbon bomb refers to the massive and potentially rapid release of greenhouse gases from permafrost, which could dramatically escalate climate change. If even a fraction of the carbon stored in permafrost is released, it could make it extremely difficult to meet global climate targets, such as limiting warming to 1.5 degrees Celsius or 2 degrees Celsius above pre-industrial levels. It's like sitting on a ticking time bomb, where the potential consequences could be catastrophic if not addressed promptly. This scenario underscores the urgency of understanding and addressing permafrost carbon release in global climate policy. 6. Thawing hotspot. Certain regions experience abrupt permafrost thaw, creating thermokarst landscapes with lakes and sinkholes that release large amounts of methane. The Yedoma region in Siberia is particularly vulnerable, containing a substantial carbon stock that can be rapidly released when thawed. Imagine a sponge filled with water. When squeezed, the water gushes out. Similarly, as Yedoma thaws, it releases its carbon stock into the atmosphere. These hotspots are critical areas of study, as they can provide valuable insights into the processes driving permafrost thaw and its potential impacts on global warming. 7. Environmental impacts. Thawing permafrost can lead to significant landscape changes, affecting local ecosystems and wildlife habitats. As the ground destabilizes, it can disrupt the delicate balance of these ecosystems, leading to shifts in species populations and distributions. Additionally, infrastructure in permafrost regions is at risk, as thawing can cause the ground to collapse, leading to the failure of buildings, roads, and pipelines. It's like building a house on a foundation of sand. As the sand shifts, the house becomes unstable. These environmental impacts highlight the broader implications of permafrost thaw on both natural and human systems. 8. Global implications. Current climate models may underestimate the impact of permafrost carbon release, potentially leading to more rapid and severe climate change. There is concern that permafrost thaw could reach a tipping point beyond which it cannot be stopped, leading to uncontrollable carbon release. This tipping point represents a critical threshold, where small changes could lead to irreversible consequences. As scientists work to refine their models, understanding the potential global implications of permafrost thaw becomes increasingly important for developing effective climate strategies and policies. 9. Research and monitoring. Scientists use satellite data to monitor changes in permafrost regions and track carbon emissions. These observations provide valuable insights into the rate and extent of permafrost thaw. Field studies complement satellite data, allowing researchers to measure permafrost temperatures, greenhouse gas emissions, and the rate of thaw on the ground. These efforts are akin to taking the pulse of the Earth's frozen regions, providing critical information for understanding the dynamics of permafrost and its potential impact on global climate systems. 10. Mitigation and adaptation. Reducing global greenhouse gas emissions is critical to slowing permafrost thaw. Efforts to curb emissions can help mitigate the release of carbon from thawing permafrost, reducing its impact on global warming. Additionally, communities in permafrost regions need to adapt to changes, such as building infrastructure designed to withstand thawing ground. It's like preparing for a storm. By taking proactive measures, we can reduce the potential damage and ensure the resilience of affected communities. 11. Policy implications. International climate agreements and policies must account for permafrost carbon feedbacks to effectively combat climate change. The Arctic Council, an intergovernmental forum, plays a crucial role in addressing issues related to permafrost and climate change in the Arctic. Coordinated efforts at the global level are necessary to address the challenges posed by permafrost thaw and ensure the effectiveness of climate policies. These policy implications underscore the need for collaboration and commitment from nations worldwide to address the growing threat of permafrost carbon release. 12. Unknowns and uncertainties. There is uncertainty about how quickly permafrost will thaw and release carbon. The full extent of permafrost carbon release and its impact on global warming is still being studied. These unknowns present significant challenges for scientists and policymakers, as they work to develop accurate predictions and effective strategies to address permafrost thaw. Despite these uncertainties, understanding the dynamics of permafrost and its potential to release massive amounts of carbon is crucial for developing effective climate strategies and preventing a carbon bomb scenario.